Okay, so we're going to look at the next section. This is a big section, a lot of stuff on climate change and global warming on your ACE exam. So we're going to be looking at human impacts on water supply. And the first thing we're going to be looking at is the impact of global warming on the hydrosphere. So I know we kind of looked at the effects of human use on the supply of water. That was more like us drawing water out and type of things like that. We're going to look now at specifically like deep dive into that. And the first one we're going to look at is how is global warming or climate change contributing to the water supply on Earth. We're going to hit up climate change probably in every sphere a little bit. I know we didn't talk about much in the lithosphere, but it is contributing to everything. So let's go ahead and take a look at this. All right. So we've already we have seen evidence and know why it happens. Now we're going to look at the effect that global warming has on the hydrosphere in particular. You may have heard of sea level rise as an impact of global warming, but why would that happen? All right. So think about ice. Ice is water. Ice is in water. If ice is in water, when it melts, why does the sea level rise? Well, here's the deal. The ice that we're concerned with are glaciers and ice caps, mainly that are above the sea, all right? So this stuff is sticking out of the water. It's not floating on the water, it's structures. When this melts, it melts down and fills more of the water, raising the sea level, and it absolutely is doing this. We have seen major evidence of sea level rise, especially since the early 1900s with the Industrial Revolution, all right? But the part you see, the part above the sea level melts, it falls into the sea, increases the sea level, and does so drastically. Also, if the ocean warms, the water expands due to increased movement of molecules, all right? It's just the way of things, all right? And the sea level will rise. So you can see this graphic here that shows the different ways sea level rise. Obviously, melting of glaciers, exchange of water stored on land by glaciers and ice sheets that then melts into the water. As the ocean warms, water expands. Surface and deep ocean circulation changes can cause sea level rise as well. Also, terrestrial water storage and extraction of groundwater, building of reservoirs and dams, all the stuff that we've been talking about, can also cause then more runoff, and that will cause sea level rise as well. So we're seeing this currently. Here is the graph that we have. And you have the years from 1880 to 2020, and the sea level change. And this is in millimeters, so you wouldn't think of it being too awful big, but 250 millimeters of sea level change is a lot. The more there is a major difference in your sea level rise and how far in then the tides will go. It is not a 1-to-1 ratio. So the higher sea level goes, the way further it will go and land and cause more flooding, and we're seeing this all over the place. Okay, so why is it bad? What are the potential impacts of rising sea levels? I'd like you to read this article from the Washington Post on sea level rise. It's getting faster. Sea level rise is getting faster. It is from 2017, so it's fairly recent. But please read about that. And as well, there is this awesome viewer from NOAA that can show you the different sea level rises, and this is something you definitely should be looking at. And you can see this is really cool. You can actually move up and down sea level to see where it will go, and then you can look and you can zoom into any coastal area of the United States and see what's getting more flooding at that time, and you can definitely even zoom into us. Tampa seems to get a little bit worse than us, and what's going to be flooded? Is your house going to be flooded if we're 5 feet in the future? 8 feet. All right, definitely we're all going to have some issues at 8 feet. And you can definitely see different stuff that's going to happen. You can play with all the stuff on the left. You can even put your address in, and you can then even do some management strategies on here as well. So please play around with that. Okay, around the world, low-lying areas, what's going to happen because of sea level rise? They're going to become more vulnerable to increased flooding. Coastlines move inward. This has happened in Earth's past with climate change associated with ice ages. coming and going. But those happened very gradually over a long amount of time, and it was either happening before humans had populated the Earth or very little human population to worry about. We're in a different scenario now. People like to talk about, well, wasn't the climate like this 800,000 years in the past and everything was fine? Well, there weren't humans then, okay? We need to talk about human survival. Yes, the climate has changed, and it's changed worse than whatever we could do to it. But all of those changes happened gradually, and there weren't humans to live on the Earth. What we're concerned with, of course, is human survival. And so one thing that could put stress on human survival is if mass amounts of people have to move, if cropland is turned into deserts because it's not getting enough rain, and then deserts are turned into cropland, it's not easy just to switch things around. This is going to put major strains, economic strains, and basically stress on the human population. The rapid pace we are adding greenhouse gases to our atmosphere is changing the climate too rapidly for us to be prepared for the change. In fact, we are nearly as high on sea level as we've been in the past 400,000 plus years, and we're projected to rise. So you can see the carbon dioxide and temperature. We're going to talk about this more in the atmosphere about why this happens. But the greenhouse effect is real. Basically what happens, it's the reason we are allowed to live, actually, or we can live on Earth, is the greenhouse effect. These greenhouse gases, what they do is they let solar radiation out, and then they block it because it has less energy after it hits the Earth from coming outside the Earth quickly. It does go through, but it goes through a lot slower than it came in. And so when you have this, you basically are able to trap heat inside. Well, the more greenhouse gases you put in, the more heat you're trapping, and so we're actually rising our temperatures up and our carbon dioxide. And you can see this is 400,000 years in the past. And we can see fluctuations in carbon dioxide, which is the green line, and the red line, which is the temperature and the sea level. They go hand in hand. This is correlation and causation. These do go in hand. I mean, obviously, the higher temperatures, the higher sea level there is. It's just what happens, okay? So you can see it ebbs and flows and goes up and down, right? And you would think, okay, this is great. But remember, this is a big, big scale. Presently, we are not here on the graph. We are up here with our carbon dioxide level. Actually, we're even further. We're over 400 now. It's rapidly increasing more than anything we've seen in the last 500,000 years. And so what's happening there is obviously we're having an increase in temperature, and that always follows the CO2. So the increase in temperature is following, and we shall see what happens, but obviously the sea level is rising as well. You can see here this awesome video put out by NASA about rising sea level and what has happened recently. Please watch that as well. And again, I don't really want to play something during class or during this because I don't like videos within videos. There are highlights from the 2014 National Climate Assessment to see the impacts climate change can have on our water supply as a whole. This is the National Climate Assessment from the United States. So you guys can please look at that. You can see the different impacts water supply is going to have on, or sea level rise is going to have on water supply. And please do read through that as well. Okay, and so we're going to get into climate change more in the atmosphere unit, but if you want to explore the NASA climate change site here and the NOAA site there, they have lots of great information on that. So that's just an introduction to just the sea level rise aspect of climate change.